Looking at some more examples. In your textbook, we have example 9. And part A gives us y equals 2e to the power of x plus e to the power of negative 3x. Okay, well, we have the addition law here. We've got two functions. So everything that we learned last week, we will be applying over and over and over again throughout the course in more complicated differentiation. So we've got two functions here that are added together. Addition rule, we take the derivative of the first and add it to the derivative of the second. Okay, now let's take a look at this. 2e to the power of x. Okay, if we were not sure what the derivative of that is, but we do know that the derivative of e to the x is just e to the x, then we could use the product rule. So we could say u is 2 and u dash, the derivative of a constant, is just 0. V is e to the x and v dash is just e to the x. Another aside over here, e to the x. This still follows this rule. So if y equals e to the x, okay, our function is only x, so the derivative of that would be itself multiplied by the derivative of the function in the exponent, and that derivative is just 1. So another reason why the derivative of e to the x is just e to the x. All right, so back to over here. Then we would have just this portion here. Derivative would be u dash v plus uv dash, which would be u dash 0 times v e to the x plus u, which is 2, v dash, which is e to the x. So that's 0 plus 2e to the x, 2e to the x. Okay, so you can see e to the x with a coefficient, the derivative of that is just itself again. Okay, so I will erase this, get it out of our way. Now we have the derivative is equal to 2e to the power of x and plus the derivative of the second function, which is itself multiplied by the derivative of the exponent function, the function that's in the exponent. So simplifying as best we can, and we have this answer. Part B, y equals x squared e to the power of negative x. Okay, so here we have a function multiplied by a function. We are going to be using the product rule. All right, so let's let u equal x squared. So u dash will be 2x. Let v equal e to the power of negative x. So v dash will be e to the power of negative x times negative 1. So negative e to the power of negative x. Then the derivative is u dash v plus uv dash 2x multiplied by e to the power of negative x plus x squared multiplied by negative e to the negative x. So we have 2x e to the negative x subtract x squared e to the negative x. Okay, if we wanted to, we could factor something out here. We could say x e to the negative x 2 minus x. And we could even move that e to the x to the denominator. So we could even write this as x 2 minus x over e to the x. Okay, all those answers are correct. Okay, you could even leave it in this form. But those are ways of simplifying. And part C, for example 9, y equals e to the power of 2x divided by x. Okay, so two ways of doing this. We've got a function divided by a function. We could use the quotient rule. So let's do that. We would let u equal e to the power of 2x. So u dash is e to the power of 2x multiplied by 2. V equals x, so v dash equals 1. Derivative u dash v subtract uv dash over v squared. Fill in the things that we just calculated. V was x and it is squared. So 2x e to the 2x subtract e to the 2x all over x squared, and we could factor out an e to the 2x to have 2x minus 1 all over x squared. All right, another way of approaching this, again, there's lots of times there's more than one way to skin the cat. We can, as long as we're following the rules of algebra, we should get to the same answer. So we could say that this function is e to the power of 2x multiplied by x to the power of negative 1. And then we could use the product rule. So u would be e to the power of 2x. Now be careful with your notation. Here it seems a little iffy that that 2 is in the is an exponent, so I'm going to redo that. To the power of 2x. So u dash is 2e to the power of 2x. V is x to the power of negative 1, so v dash is negative x to the power of negative 2. And use the product rule. The derivative is simplify. We have 2e to the 2x over x plus e to the 2x over, oh, it's not a plus, it's a subtract. Oh, put my eraser in the wrong place. Subtract x squared. Common denominator, 2e 2 to the x times x over x. Two x e to the 2x over x squared minus e to the 2x over x squared, which we could then simplify into this exact same thing. Okay, example 10 from your textbook. Part A. We have y equals e to the power of x minus 1 all cubed. Okay, so we're going to be using the chain rule here. So the derivative is, bring the 3 down, keep the bracket, decrease the exponent by 1, and also multiply by the derivative of inside the brackets. 3e to the x, e to the x minus 1, all squared. And part B, y equals 1 over the square root of 2 e to the power of negative x plus 1. Okay, in this case I think it would be easier to reconstruct this to look like 2e to the power of negative x plus 1, And that is actually to the power of negative 1/2. And then we can use the chain rule again. dy dx. Other ways of solving that would be using the quotient rule. So negative 1/2, 2e to the negative x plus 1. Decrease your exponent by 1, so negative 3/2, multiply by the derivative of in the bracket, so 2e to the negative x, which is then multiplied by negative 1. And we need to simplify. This is negative 2e to the negative x. So negative 1/2 times negative 2 is just 1. So e to the negative x times 2e to the negative x plus 1 to the 3/2. Oh, and that's supposed to be negative 3/2. Okay, so we could say 1 over e to the x times the square root of 2e negative x plus 1, which is cubed.